Hello students, welcome back to the mathematics class once again. In today's video lesson, I am going to discuss with you a new chapter of class 9, that is lines and angles. So this lines and angles, today we are going to deal with the introductory part, the concept video and also the exercise. Okay, here those who have not watched the previous chapters, so these previous chapters which we have dealt, they are in the channel playlist. Okay, so the many students are giving their comments in the comment section that please tell the second chapter ma'am, first chapter ma'am, likewise. So all the chapters are being uploaded in the channel playlist. Please children, go to the channel playlist and you can see all the chapters. Whichever you want to observe, you can click on that particular chapter. Okay, now today in this lines and angles chapter, the introductory part of the basic concepts today we will know. Now you all know a point in a plane. This is called a point. Yes. Now infinite number of points, if you join, you get a line. Okay. So on the line, a line is formed by joining all infinite number of points. Now if I take a line and if I draw two arrows, this line can be extended to this side and this line can be extended to this side. Infinitely I can extend the line. So this is called a line. It can be extended infinitely. Now if I take one point on this line as P and another point as Q and another point as R, likewise. So these are the points on the line. Okay, so if I take PQ, the part from here to this, a part of that line, then I call this as a line segment. Okay, so this is a part of the line, so it is called as line segment. Segment itself means a part of a line. So PQ is a line segment, QR is a line segment. Likewise, we can take PR. PR is also a line segment of this complete line. Okay, and when we are seeing a line, now I take a point here and I extend a line here to this direction only. This is one end point, let us suppose O, and this is in towards this direction. Now this I call it as, so this is a ray towards this direction. So ray is having a end point and it is the direction is showed through a arrow. So the direction is towards this. Now we all know the sun's rays, right? The light rays. So from that point of end point towards which it is protruding, that is called a ray. So OA is a ray. Whereas if you take a line which can be extended to that side as well as this side, that is a line which can be extended, and a part of a line is called a line segment. These are the basic concepts of lines. Now when you are taking one ray, suppose this is the initial position of the ray. Let me take here. So O is an end point and OA is a direction, A towards A, the direction. So this is a ray. And when the ray is at the initial point and when it is forming some angle, that means angle formed from the initial position of a ray to a terminal position. Now the terminal position let me suppose as OB. Okay, so this is the angle formed. So what is an angle? An angle is, so how an angle is formed? When a ray is moving or rotating from an initial position to a terminal position, an angle is formed. So we can measure this angle using a protractor. We can write the measure of this angle. Now here in the angle formed, these OA and OB are rays, isn't it? OA and OB are rays. Okay, these rays are called the arms. Okay, arms of this angle. And the end point of this OA ray is O and the end point of OB ray is O only. And the common point is nothing but the vertex. This is called vertex. Vertex is O. Okay. So these are called the arms of the angle. These rays are called the arms and this common point is called the vertex. So this is about angle. Now our chapter is lines and angles. Now also we have different types of angles and different types of lines also. Let us discuss that also. Now when we, all these concepts you have read in your lower classes also, but we will revise once again. Okay, now the angle is this formed by a ray from an initial position to the terminal position. Okay, when the angle is below 90 degrees, okay, that means when the angle is in between 0 degrees and 90 degrees, so that angles are called as acute angles. Okay, acute angles. So if I suppose x is an angle, so x should be less than 90 and greater than 0. So the angles formed between 0 and 90 degrees are all called as acute angles. Similar way, when the angles are above 90 and below 180, so like these angles, these are called, if I suppose y is in between 90 and 180 degrees, those are called as obtuse angles. So the terminal ray is after 90 degrees and below the 180 degrees. So the angle formed, so y angle, this is y angle, is greater than 90 and less than 180. So such angles are called obtuse. Similar way, if the angle is forming like this, here is the common point, that is the vertex, and if the angle is like this, this is called as a straight angle. Now it is forming a straight line, so it is called as a straight line, straight angle, which is 180 degrees. Similar way, we have an angle like this, that is, all of you know this is a right angle. We usually keep a box shape, it means it is a right angle 90 degrees. And after 180, if the terminating ray here, if it starts in the initial position, comes to here, and if it makes one complete rotation, such angle is called as a complete angle. See here, it is starting from here, it is moving on, coming to one complete rotation. So if it makes complete rotation, that is here 180 and 180, that is called 360 degrees. So that is called as a complete angle. So these are the types of angles you need to know before going into the exercise problems. And one more angle is there, that is, if this is the vertex and this is the initial position, here if the angle is moved after till here 180 and after 180, if it is moved here, this angle is called as a reflex angle. If I suppose this as Z, so Z angle should be greater than 180 and less than, see, after greater than 180 and here less than 360. Okay, so this angle is called as a reflex angle. We call it as a reflex angle. Yes, so it is after 180 and less than 360. These are all called reflex angles. So these are all the types of angles. Now when we see the lines, we will see, please pause and note the notes. We have known all the types of angles. Now here we will know about the types of lines here. Now intersecting lines, parallel lines and concurrent lines. What are they? Here, if you are taking any two lines, yes, the lines, as we have discussed, that the line can be extended infinitely to this direction and to this direction also. Yes, if there are two lines and they are not having a common point, there is no common point for these two. So this line is towards this and this line is towards this. Such lines are called as parallel lines. They do not intersect, okay, and they are not having a common point for them. Whereas intersecting lines are the lines, if you are taking two lines here, this is line L, this is line M, here line L and line M. If these lines are intersecting at one common point, they are called as intersecting lines. Now what are the concurrent lines? So here we have one common point. Here we don't have any common point between these two lines here. And we also say non-intersecting lines means two lines which are not at all intersecting even though they are extended. So in non-intersecting lines can be parallel lines also. Here we also say these lines like this. These two are non-intersecting, but if you extend them, at some point they intersect. Okay, so at one position they may be non-intersecting also. Now here, what are concurrent lines? Now concurrent lines are the lines where three or more lines. Now here I am taking L, M, N. These are the lines. Okay, and also let me take O line. Okay, so all these lines are more than two. So when three or more lines are intersecting or are meeting at one common point, they are called as a concurrent lines. Here in intersecting we have only two lines meet at one point, that is called intersecting point, and here three or more lines meeting at one point, they are called as concurrent lines. All these are concurrent lines. L, M, N and O are concurrent lines where the point where they meet is called as the point of concurrence. It's called as point of concurrence. So this is all about the lines. Now we will see a pair of angles, right? Let us see pair of angles here. So if you are taking two angles, now the angle is formed by rotating a ray from its terminal, from its initial position to the terminal position. Okay, that is the angle form. Now pair itself means two. Okay, two angles, when they are called as complementary, we will know here what are complementary angles. Okay, the complementary angles are that angles when they sum up to, if I am taking here 40 degrees angle, this is one angle, and if you are taking here 50 degrees. So I say these two are complementary to each other. These two are complementary angles. That means when these two sum up to 90 degrees, we call it as a complementary angles. Okay. Now, likewise, if you are taking a 90 degrees here as here 30 degrees, this is 60 degrees. So these two angles are called complementary. If one angle is given, the complementary angle, we can find it by subtracting from 90. 90 minus this angle, you get the complementary angle. Likewise, we have another pair of angles, that is supplementary angles. The similar way where they sum up to 180 degrees. The pair of angles when they sum up to 180 degrees, they are called as supplementary. Like if you are taking this as 140 degrees, this is an obtuse, and if you are taking this as 40 degrees. So if these two angles sum up to 180 degrees, they are called supplementary. So one is for the other, these two are pair, and if anyone asks about 40 degrees, what is the supplementary angle, we have to subtract it from 180. Okay, so these are supplementary angles. Next type is conjugate angles. Sum up to 360 degrees, the pair sum up to 360 degrees, it is called as conjugate angle. Okay, so if one angle is suppose 170 degrees, okay, angle X. Now how do we get the conjugate angle for this? If I suppose angle Y is a conjugate angle, so if you subtract from 360, you get the conjugate angle. So this becomes 190 degrees, right? Yes. Now moving on to the exercise problems. Exercise we have 4.1. In that exercise, the first one I'll read out for you. In the given figure, name any 6 points, any 5 line segments, any 4 rays, any 4 lines and any 4 collinear points. Now the collinear means points on a same line, on a single line. The points which are on a same line, they are called as collinear points. Okay, any 6 points. Seeing the figure, you can easily give any 6 points. Points, you can take anything that is point A, X, M, okay, P, so on. So any 6 points, so you can write 6 here. So N is there, Q is there, these are all points, okay. And any 5 line segments, so I am writing only the solutions here. The question is there in the textbook, okay. Any 5 line segments seeing the diagram. You can take a line segment AM, okay. You have to denote it like this. We can take line segment MP, any 4 you can write. You can take line segment EM, you can take GP. So many are there, but 4 are asked, okay. Any 4 rays. Rays means it should show the direction, okay. The line segment which is showing the direction, you can take PB ray, okay, here ray, and the same thing, PG ray also you can take. We can take NF ray, and we can also take QH ray. So there are many rays. Any 4 you can write it, okay. And any 4 lines, if you take, see here, lines are AB line, CD line, EF line and GH line. AB, CD, EF and GH, okay. So these are the lines which can be extended infinitely, okay. And any 4 collinear points, so on the same line, the points lying on the same line. So if you are taking one line, let me take any one line. So I'll write E, M, N and F. These are the collinear points on the line EF, okay. So, and the second question, observe the following figure and identify the types of angles in them. See, there is a clock given, there is a ruler type scale is given, and there is a carom board. Here asked us not to find the measure but the type of angle. So the types of angles just now we had read. Here if you see angle A in the clock, angle A in the clock is reflex angle. Remember, it is reflex angle. It is more than 180 and less than 360. So not asked the 8 o'clock this side if it is asked, then we say it as an obtuse, but it is asked A, that side it is there. And the angle B, angle A is reflex here, angle B here is right angle, clearly 90 degrees. So box angle also we can call right angle. And angle C is, the type is asked. So the angle C is here in the carom board, that is an acute angle. It is less than 90 degrees. So here mentioned, asked us to find the type of angles seeing the diagram. Now moving on to the third one, which is a true or false question. State whether the following statements are true or false. A ray has no endpoint. No. It has an endpoint. Okay. From endpoint towards the direction it moves. So it is called a ray. So that first one is false. Third one. And the second one, I'll read out for you. Line AB is the same as line BA. Yes, true. It is same as the line BA. Okay. Now, a ray AB is same as a ray BA? No, because the directions are changed. AB ray might be towards this side and BA towards the other side. So, it is false. The directions are different in rays. Okay. The fourth one, a line has a definite length. No, as I told you, a line segment has a definite length because the segment is having endpoints. Whereas a line can be extended towards infinitely towards both the directions. So, it is false statement. Now, a line has length and breadth but no thickness. Yes, true. It has length and also breadth but it has no thickness. Okay. So, that was true. And the sixth one, two distinct points always determine a unique line. Yes, two distinct points will determine a unique line. Right. They are the points can be mentioned here because as we know, on a line we have infinitely number of points. So to mention that line, segment AB, so 2 distinct points should be there. So that is true. Okay, moving on to the 7th one. 2 lines may intersect in 2 points? No, never. 2 points. So the intersecting line, they intersect at only 1 point. So no 2 points will be intersecting points there. And the last one is 2 intersecting lines cannot both be parallel to the same line. Okay, if there are 2 intersecting lines, if these lines should be parallel to another line, so this is parallel to one line, but this line is not parallel, so it cannot happen. So and they are given cannot, so that is true. This is true. Now moving on to the last one. What is the angle between 2 hands of a clock when the time in the clock is 9 o'clock? So this is quite interesting here. See here, when it is 9 o'clock, see if you are seeing this is 9 o'clock. But here the angle is not here. When you are seeing the clockwise, anti-clockwise, the angle moves like this. Here, when it is 9 o'clock, it is 270 degrees. Okay, this angle you have to measure, right? And when it is 6 o'clock, so this is A bit. When it is 6 o'clock, it is clearly 180. The 6 o'clock means the angle, it is a straight angle, right? So here we have all the 12 parts, and this complete angle is 360 divided by 12. One part you get it as 30 degrees. So for 5 minutes it moves 30 degrees angle. That you have to remember. And at 7 p.m. see here, 7 p.m. So 7 p.m. means toward here. So till here it is 180 and 30 degrees if you add. So 180 plus 30 degrees is 210 degrees at 7 p.m. So each 5 minutes is 30 degrees. So likewise you can calculate the angle for any clock of the time. So we have completed this exercise today. We will move on to the next exercise in the next class. Thank you all.